Okay, so we're going to talk about theorems that involve parallel lines in section 5.3. The first part you got to understand for this first theorem here is that each of my 4 lines that you see are evenly spaced. Okay, they are even. Do they look evenly spaced to you guys? Yeah. So I'm going to go ahead and write that down just to make sure that we all know that. Okay, so each of these are evenly spaced. Okay, so if they're all spaced evenly there, then here's the deal. If I have 3 or more parallel lines, and then I take another line, which will be my transversal, and I cut right across that, and I'll make this like a big purple line for you guys. Okay, so the purple line is my transversal. Okay, yeah, draw a transversal across all 4 of your evenly spaced parallel lines. And how do I know those lines are parallel, by the way? Little arrows, right? So here's what this says. It says that the space between each of the lines will be congruent on that transversal, no matter how we do it. Okay? So let me give you another example, right? Let me draw another transversal, kind of at a different angle here. And I'll make this one red so we can see the difference. Alright? Here's what it's saying. This space here is the same as this space here is the same as this segment there. That's what it's saying. No matter which way you put the transversal, if all lines are parallel and evenly spaced, then you get the congruent segments. So we're going to write that out. So here's what it says. If 3 or more parallel lines, so my lines are L, M, P, and Q. If 3 or more parallel lines cut off congruent segments of one transversal, so the purple one. So these are the congruent segments that I'm talking about. So this congruent segment, this congruent segment, this congruent segment. If that happens for one transversal, the theorem says it's going to happen for every transversal, such as the red one or any other line I could draw. Okay, so see my new blue transversal. What does the theorem say?
Those are all congruent segments.
It's where are the congruent segments? That segment is congruent to that segment is congruent to that segment. That's what the theorem is saying. So theorem number 2. It's an if-then statement. It's involving a triangle in this case. So here's the deal. If I take one of the sides of the triangle and I find the midpoint, would you guys say that's about the midpoint of that segment right there?
Sure.
Okay, I would say that's about the midpoint, right? Okay, so that means that this segment and this segment are congruent to each other. Is that true? That's what midpoint means? Okay, all right. So, if I take a segment from that midpoint and draw it parallel to the base, okay? So if I find the midpoint of one side of the triangle and I draw it parallel to the base, what do you think this point is guaranteed to be? There you go. It's guaranteed to be the midpoint of the other side. That's what that says.
Oh my goodness.
And again, here's what it says in words. If a line containing the midpoint of a triangle, so the line that we're talking about that contains the midpoint of a triangle, that's this line here, the line that I'm highlighting. If a line containing the midpoint of one side of a triangle is parallel to another, so that means it's parallel to this one down here, right? Cool with that part? Then it will contain the midpoint of the third side. So here is the third side. I'll highlight that in blue for you. Here's the third side highlighted in blue. And look, it has the midpoint right there. That's what that means. Okay, here's the setup for the third theorem for us. Okay, so you have this triangle drawn. Here's what we're going to do. Oh, we're not quite ready yet. Okay, we have this triangle drawn. We're going to find the midpoint of the left-hand segment there. So I'm going to take a green pen and I'm going to find the midpoint of the left-hand segment and call it right there. Fair enough, you guys? Fair enough, good. Let's find the midpoint of the other segment. So I'm guessing it'd be, I don't know, right about there. Is that close enough? Okay, so if I have my 2 midpoints, then I'm going to connect my 2 midpoints with another segment. just like that. It's in green right there. You guys good with that part? So the theorem says this. So here's what this is saying. It says a segment that joins the two midpoints of two sides of a triangle. So the segment that I'm talking about is this highlighted segment here. So the segment that joins those two midpoints is guaranteed to be parallel to the third side. That's what this is saying. And the third side is down below. Now you get an extra bonus with this particular theorem. This segment here, I'll do this in red. This segment here, the length of this one is exactly half the length of that one. You get a bonus. Yeah. Yep. I will. Okay. This segment, the segment that does this, right? This segment is 1/2 of this segment here. That's another theorem.
Always?
Yep.
How?
So kind of fun. We took this and we moved it. We said, whoa, check it out. It really is about half. Look at that right there, about half of that. That's what that's saying.
Now drag it onto the other side.
See it? There you go, right there.
What's this?
That's crazy, huh?